Hi, I'm Jacinta Delhaize. I'm a postdoctoral researcher at the University of Zagreb in Croatia. I'm an astronomer, and today I will describe my latest research paper on the mysterious infrared radio correlation. So our story begins with the Carl G. Jansky Very Large Array, or VLA for short. This is a powerful radio telescope in New Mexico in the USA. Our research group at the University of Zagreb, along with our international collaborators, won almost 400 hours of time with the VLA. We used it to look at a patch of sky called the Cosmos field. We made a radio map of this patch of sky, and in it we identified nearly 11,000 galaxies existing out to the far reaches of the universe. We compared this radio data with other maps made of the cosmos field at far infrared wavelengths with the Herschel Space Observatory. This is some of the highest quality radio and infrared data that exists, and with it we were able to conduct one of the most advanced studies of the infrared radio correlation of galaxies. So what is the infrared radio correlation? Well, you might know that stars form inside galaxies, and some of these stars are very massive. Massive stars can heat the dust clouds that surround them, and this dust then glows in the infrared. After a few million years, these stars explode in dramatic supernova explosions, which can accelerate electrons to nearly the speed of light. As these electrons interact with the magnetic field of the galaxy, they release radio light. So it's probably because of these stars that we see that the amount of infrared light coming from a galaxy is closely related to the amount of radio light coming from the galaxy. And this is called the infrared radio correlation. Astronomers found this relation all the way back in the 1970s. But our work has shown that this correlation seems to have changed over the history of the universe. We found that compared to the amount of infrared light, galaxies that existed in the early universe released more radio light than galaxies that exist in the present universe. And this seems to match what other astronomers have found using different data. We're not yet sure exactly why the infrared radio correlation has changed this way, but we have a few ideas and we're working on understanding it. These results are important because we can use the infrared radio correlation to figure out how many and how fast stars are forming in distant galaxies. And we need to know this so that we can understand how and why galaxies have changed or evolved since they formed after the Big Bang. The future will be very exciting. We're going to learn a lot more about galaxy evolution using next generation radio telescopes such as the Square Kilometre Array. And our data and our results will help to prepare for this. So stay tuned in to Radio Astronomy, and thanks for watching.